This slide compares and contrasts the arrays that you're already quite familiar with the new thing that you're learning about right now, the array list. So we've declared an object of class string, and it's an array of strings, and we're calling it A. This is on the left-hand side in the middle column marked array. And so you can think that A stands for array. And on the right-hand side, we're declaring an array list instead, and we're calling it list. So the name list for array list, and on the other side the name A for array. And now we're comparing the two together here. In either case we have an array of strings, whether it's A or list. But in the case of A, it has some limitations that we talked about earlier that don't exist with array list. Array list is much more flexible and powerful. So let's start with the top line. How do you initialize these things? How do you create them? How do you declare them? So in the one case we would say string, and because we want an array of strings, we follow that up with a pair of empty square braces. Then we give the name of the object, A in this case, A for array, equals new string, and then in square brackets how many elements we want to have in our array, in this case 10. By comparison, to do the same thing as an array list, we would say array list, and then in angle brackets give the type of the object that we want to be able to put in this array, in this case string. Then we give a name to our newly created array list, and we call it list in this case. We say equals new array list, and notice the square braces or the angle braces are empty because the compiler will infer from what we've put on the other square braces that this has got to be an array of string that we're creating. And there's no arguments in the round parentheses because there's just a no-arg constructor that just creates an empty list in this case. Moving on to the next line then, to access a particular element, in the case of an array, we would say a sub index. Whenever I say sub, I mean square brackets with an integer inside. In this case, the value of that integer, or the name of the integer would be index, but it's going to always be an integral value, 0, 1, 2, 3, etc. And that's how we would do it with a regular array. So you're very familiar with that already. In the case of the array list, however, we have a method to do that. So now it's not a subscript, but it's an index that we pass as an argument, an integer index. So we say list.get, and then in round parentheses, the argument representing the index that we want to get from our list array. The next line, the third line in this chart, talks about how to update an element. In the case of an array, you would say a sub index equals, and then you'd give the name of the new value that you want to update the old value with. For the array list, we would instead say list.set, and we would give the index of the element that we wish to update, followed by the new value. So two arguments in parentheses in this case. To return the size of an array or an array list, this is the fourth line in our table here, we would simply say a.length in the case of an array, and in this case of an array list we would say list.size empty brackets, because this is now a method, not a data member, so we need the parentheses to indicate that. In either case, either of those would tell us how many elements were currently stored in the array. Now that's it for regular arrays. You can see that the rest of the column is completely blank. There are not methods to directly produce the rest of the operations that are described in the first column. But with the array list, we have a number of more operations that we can talk about. So let's just go down that first column. So we can add a new element to the array, we can insert, we can remove either a specific element or an element at a particular index, and we can simply remove all elements in one foul swoop. So let's talk about how those 5 different operations take place. In the case of adding a new element, we simply say list.add and give the new value. So this is obviously going to append to the end of the list. But if that's not good enough, if we want to add an element at a particular place, then we would say list.add, and then we give the index and the value to be added. And remember, in our demo you saw that what happened when we did this is all the elements that were already in the list scooted over to make room for the new element at the particular index that was specified. To remove an element at a particular index, we would say list.remove and give the index as an argument or a parameter to that method. Again, remember what will happen is the element is removed and all the following elements, if there are any, would pull back one index to fill the void left by it. Removing an element by specifying its particular value, we would say list.remove and give the value of the object that we wish to remove from the list. And if that object is actually present in the array list, it will be found, removed, and if it's not already at the end, if it's somewhere in the middle, then all the remaining elements would pull back by one to fill the void once again. And finally, we can remove all elements in one fell swoop simply by saying list.clear, and the array list becomes empty when we do that.